इसको बंद चालू कर ले एक बार माइक को। हेलो हेलो, हाँ तो रिकॉर्ड हो रहा है।
Okay, ठीक है. Okay, so now we are starting the simulation for this example map given here. Uh, we are now in our forward state. Uh, we have options of uh, having a right section, a left section, a T section, a dead end, and these are drifting left and drifting right states, which basically are used for correcting the forward motion. So right now we are at start. For init, we have for for the init state. Now we have forced the robot to go forward in the forward state. So we are going in the forward direction until we reach this left section. Now we are using continuously. We are doing a wall following maneuver, which is taking only left turns whenever possible. So like it follows the left wall to cover the entire boundary of the uh, given path, so that we can cover the entire path and we can get the goal eventually. So here we take a left. Uh, Now after left, we have automatically come back to our forward state. We keep moving forward. We keep moving forward. Again, we come to a lefty section. We take a left. Uh, Again, we start moving forward. We are again have a left section here. We take a left action again. Now we have a right. We have a right section here. So we have right section. We have an option of whether we move a small distance forward and see if we get a dead end or a straight path. So that since we are choosing only the leftmost trajectories, leftmost paths, if we don't include the straight path for a right section, we will be missing out on exploring a particular segment of the path. So hence we are moving some distance forward. Here after moving forward, we get a dead end. So uh, I'll show you here. We get a dead end. The robot moves backward again since we have a dead end. Here we took we before moving forward, we were at a right section, so we are again at the right section only. So here we take a right and we start moving forward again. So the similar process will be followed for this right. Uh, so I'll just skip those two moves. Here we keep on moving forward. Here we have a right where we also have a particular path for in the forward direction. So I'll show you what happens here. Uh, we come across a right section, but after moving forward we see that there is a straight line path available, so we keep on moving straight here. So upon moving straight, we observe that we suddenly are reaching a dead end. So once we reach a dead end, uh, we come to our backward state, where uh, we are now moving in the reverse direction. So now the left and right of the robot is seen in the reverse point, like from the backward point of view. So uh, we are seeing the we are seeing now that once it comes backward, we are arriving at a left section. So we'll be taking left in reverse mode. So the left in reverse action. So we took the left action here. Again, we have a left section. Since we are prioritizing left moves, we take the left moves first before uh, exploring any other directions. If we uh, if we reach a dead end at any particular section for the left, suppose if we reach a dead end for a particular section, we'll be remaneuvering backwards like in the previous case and exploring the next path which comes after the particular order of left straight and right path. So here we are taking a left again. Now we have the right with respect to the reverse direction of the robot. We go to right in reverse. We moved a bit ahead. Here it's backward because it's the reverse direction of the robot. We saw a dead end. We again come back and it was a right section. So we take a right here. So we take a right. Again we take a right here. Similarly, we take now next there are two lefts here. So since the priority is left, so we take left in reverse and we take a left in reverse. So here we are able to complete this whole maze uh, using this algorithm. Now supposedly if we reach a T section, this is not shown here, so I'll show you that as well. Supposedly okay. So right now once we reach at the end, it will be like seen as a T section first, like because all of the states of the robot, all of the sensors will be sensing black. So once it senses it's at a probably a T section, it moves a bit forward. So if after moving forward it remains in the fully black state, we conclude that we have reached the end. So this is how our model is able to run. If we had not been if there had not been this whole completed black segments, then we would have had to basically